Turning on America, a job in which the electric utility industry has been involved for a lot of highly successful years. But over these years, something has been happening. The persistent ticking of history's clock has been measuring one of our century's most alarming dilemmas. While we expect America's electrical needs to continue to grow more vast, its energy resources are becoming more vulnerable. Signs of this vulnerability can be seen everywhere. The news media, for example, report on OPEC, the Environmental Protection Agency, the Nuclear Regulatory Commission, and acid rain. Unfortunately, as we seek alternatives, time is not on our side. But there are answers. And what you see behind me is a convincing demonstration that coal, which is a relatively invulnerable fuel, is one of the answers. Here in East Alton, Illinois, is a specially designed system. Now, it can take up to 600 tons of economical bituminous coal each day and turn it into 400 million BTUs of clean fuel per hour. Now, that's enough capacity to serve the electric power needs of a community of 10,000 people or more. No, this is not coal as we remember coal being used. Here, you see the spectacular result of coal being converted to a clean, efficient fuel gas by a technology that brings the coal industry and America to a new and promising crossroads. But let's go back and start with our basic source, coal. The United States has more than 25% of the world's recoverable coal reserves, enough to feed our nation's power plants for the next 200 years. The challenge has been how to convert this coal effectively into energy. For much of this coal, past effort has gone into burning the coal and then cleaning the stack gas. But recent research has shown that a bold new alternative lies in cleaning the coal before it's burned. For example, by gasification. That's what Allis Chalmers Corporation is doing here at the Illinois Power Company's Wood River Power Plant in East Alton. It has built the nation's first large-scale coal gasification facility to operate in an electric utility environment. See, in 1970, capitalizing on its extensive rotary kiln experience, Allis Chalmers started research and development work on a new and proprietary coal gasification program, which is now called the kiln gas system. In recent years, it's had technical and financial help from the state of Illinois, 12 investor-owned utilities, and the Electric Power Research Institute, along with appropriate consultants. The installation at East Alton shows that the kiln gas system can provide a viable alternative to pollution-controlled scrubbers with conventional coal-fired boilers, or to natural gas and oil-fired combustion turbines. And yet, for all of the kiln gas advances, the basic concept at work here is relatively simple. To explain, let's use an analogy from the family kitchen. If you were to attach a couple of taps to a pressure cooker, you could, in principle, make your own coal gas. Hook one tap to a whistling tea kettle so you can inject steam. Then attach a blower to the other tap so you can add just the right amount of air. Now put in the coal and start cooking. Allis Chalmers put principle into practice here at East Alton. This plant is gasifying high-sulfur Illinois No. 6 coal to produce a clean, low BTU fuel, which is fired in one of the Illinois Power Company generating units. The heart of this new system is a ported rotary kiln used as the gasifier. Coal is fed continuously into one end of the kiln. Air and steam are introduced through the ports near the other. They provide the oxygen needed for combustion and the oxygen and hydrogen which combine with carbon from the coal to form the product gas. But let's back up a bit. Remembering the earlier analogy, you might think of this gasifier as a sort of stirred pressure cooker. To understand what really happens inside the kiln, think of coal as an amazingly complex mixture of chemical compounds. As it's heated, several of these compounds are driven off as vapors, leaving char, which is mainly carbon. With the addition of air and steam, combustion and gasification reactions take place on the surface of this hot char. With proper control of these additives, oxygen from the air reacts with just enough of the coal to provide the heat required to keep the process going. The gasification reaction occurs when the carbon and steam molecules combine. The steam, which of course is water vapor, breaks down to hydrogen and oxygen. Then these elements ultimately combine with the carbon to form the principal working components of low BTU gas. The char contains a small amount of material which will not take part in these reactions. This material, mainly silicone and calcium oxides, is the common ash that is discharged from the end of the gasifier. Of course, a chemist would give you a lot more detail, but this is the essence of the story. After leaving the kiln, the raw gas is put through various dust, heat, and sulfur recovery steps, all of which use commercially available technology. We'll see this in a moment.
At this point, one might ask, what does this mean for producers and consumers of energy? Allis Chalmers envisions its kiln gas system serving two major markets. In the short run, there's the retrofit market to fire existing steam boilers. Now, it means low BTU gas made from U.S. coal that can replace foreign oil and natural gas. We learned in the 1970s that both could become very difficult to get and much more expensive. In the long run, there is a potentially huge market for new capacity. Now, this includes industrial as well as utility installation. Along with opportunities to fuel traditional new plant equipment, this application includes fueling the power plant combustion turbine, a cousin of the aircraft's jet engine. Combustion turbine technology holds great promise for more economical power plants.
Before we go deeper, let's expand our operational diagram to pick up the remaining steps in the kiln gas process. The coal is fed to the gasifier through a pressurized feed system. The reaction of air and steam with the coal produces the low BTU gas. The ash is removed from the discharge end of the gasifier. We got that far last time. The hot raw gas now leaves the gasifier and passes through a cyclone. Here, coal dust is separated from the gas and fed back to the gasifier. The dust-free gas then moves through a heat recovery system where its excess heat is used to make the steam required by the process. From this point, the tar removal system recycles the carbon compounds for further processing. The gas stream then enters a commercially proven sulfur removal unit, which extracts elemental sulfur for later sale. Thus, the kiln gas system effectively recovers its own byproducts. The dust and tars are returned to the gasifier, where they are broken down to make more gas. Heat is recycled to improve the efficiency of the operation, and sulfur is captured in a commercially usable form. Common ash is left for disposal. What we have then is our final product, a clean, low BTU gas ready to be burned in either a boiler or a combustion turbine to produce usable energy. The energy needed to turn on America in a new way from an old source. The kiln gas system of coal gasification thus offers a bright here and now alternative for the growing needs in today's increasingly vulnerable energy field.
With that background, let's return to the subject of kiln gas application possibilities. Here the question becomes exactly what are the chief advantages of this new system? Well, to begin with, availability. High sulfur coal reserves are not only abundant, they're available to virtually every region of the country. That means no international or geological vulnerability. Instead, plentiful supplies of coal that the kiln gas system can turn into a clean fuel gas efficiently, effectively, and economically.
The beauty of this system is that it can handle virtually any kind of feedstock, including bituminous and subbituminous coals, lignite, petroleum coke, and even fine coal particles. And it can do that without special pre-treatment or pre-sizing. In addition, whatever fuel is selected can be tested for any customer in a full-scale system here at East Alton before a new plant is designed. What's more, this East Alton plant can also be used to provide hands-on training for the people who will operate the new plants. Still, another important kiln gas characteristic is its responsiveness to quick changes in energy demand, both up and down. Simply by adjusting the amount of steam and air blown into the kiln, the operator can match the rate at which gas is produced to short-term changes in the rate at which the fuel is needed. Thus, quick changes are not required in the coal feed rate or in the kiln's rotating speed.
Of course, there's always the problem of pollution control. Well, the kiln gas system can meet today's toughest requirements. Commercially available technologies can clean the raw gas to virtually any required level. The principal waste products are well suited either to landfill disposal or resale. With regard to operating costs, those for the kiln gas system are estimated to be lower than for any other synthetic fuel system expected to be commercially available for quite a few years. Why? Well, mainly because the production of low BTU gas requires less processing than any other synthetic, but also because rotary kilns have an excellent record in the large-scale processing of bulk solid materials.
One more big plus. The kiln gas system can be used as part of a new modular power plant design that has been given the rather complicated name of Integrated Gasification Combined Cycle Plant. In this application, one or more combustion turbine generator units can be built and brought into what utility people call peaking service, using oil as their fuel. Similar units can be added as more capacity is needed, each going into productive service in a relatively short time. When this capacity is needed fairly often, waste heat boilers can be added to drive a steam turbine generator from the heat of the turbine exhaust gases. Finally, a kiln gas plant would be built on the same site so that the entire generating station could be converted from oil to coal from U.S. mines. This modular construction has two advantages. First, the owner doesn't have to build a large plant when only a little more capacity is needed. Second, if a large new plant is needed quickly, a modular plant can be built in about half the time it takes to build a conventional coal-fired plant these days. Now, that feature, of course, could save a lot of construction financing costs. Either way, the modular configuration can help utilities hold the line on rising electric power costs, a real advantage to everyone. The kiln gas operation here at East Alton is only the first of what is expected to be an increasingly important alternative, both for today's retrofits and tomorrow's new capacity needs. In fact, opportunities for such a system in the years ahead appear tremendous, and that would use a lot of coal. America's needs for electricity will continue to grow, as likely will some of the vulnerabilities of its energy industries. So the kiln gas concept being demonstrated here at the Wood River Power Plant comes as a timely here and now alternative to help solve that dilemma. It's one alternative that finally takes full advantage of America's enormous, readily available, low-cost coal reserves. Allis Chalmers heard history's clock ticking. In response, it took a promising principle and put it into productive practice. In a true partnership achievement, the kiln gas system is a successful breakthrough in the search for new energy solutions for our nation's producers and consumers. An innovative twist to turning on America.